So far, all of our conversations about collections and containers have focused on immutable collections. Immutable collections are the default type of collection used in Scala, and they fit in with Scala's strong preference for side effect free code. However, there are times when you really need your collections to be mutable, and at such times, mutable collections and arrays come in handy. Mutable collections are different from arrays. Arrays are actually technically not collections. Mutable collections can grow and shrink, and in addition, the contents of these collections can be modified. Arrays cannot grow or shrink, they have a fixed length. However, elements of an array are mutable. So, arrays are somewhere in between purely mutable and completely immutable collections. The immutable collections that we've discussed so far, lists, maps, and sets, which we have not actually discussed, all exist in the scala.collection.immutable namespace. Now it turns out that there is another namespace, kind of like a parallel universe, called scala.collection.mutable, and this namespace defines mutable versions of these collections. You should keep in mind that mutable versions of lists are called buffers. The mutable versions of sets and maps are also called sets and maps, so it's only the list which has a different name in the mutable namespace. When you create a map or a set, by default, it is the immutable version that is being created. This is in keeping with Scala's preference for immutable data and side effect free code. Let's dive into a really simple demo showing how mutable collections can be created and how they can be built up using builder objects. Instantiating mutable lists, i.e., buffers, maps, and sets is actually pretty simple. It's just a matter of specifying the appropriate namespace. Here you can see that a buffer of integers has been instantiated using the collection.mutable.buffer apply method. It contains the integers 10, 20, 30, 40, and 50. The syntax for creating a mutable map is once again very familiar. All you need to do is explicitly specify that the collection.mutable.map be created rather than the immutable version which would have been instantiated by default. In order to create a mutable list which in some way mimics an immutable version, we've got to make use of a builder object. We start by calling the list.newBuilder method. We also specify a type parameter so that we tell Scala what type of builder we specifically want. Now that we have this builder object, we pass it into the for each method on our original list. That's the immutable list sum numbers. Notice how the function literal that we specify overloads the plus equals operator of the list builder object. What we are accomplishing in this statement is to add every element of the list sum numbers into the list builder object. We can go ahead and make as many modifications as we like to this list builder object. When we are done, we use the result method of the list builder object to get back a list of integers. Value reconstructed list is immutable, and so we have come back to the safety of immutable collections. For the sake of completeness, let's very quickly address the issue of working with arrays. Remember that arrays are not technically collections, and unlike mutable collections, arrays have fixed lengths. The number of elements in an array is fixed. However, the objects contained within an array can be modified. Let's do one very quick demo showing how we can work with arrays. First up, we create an array. Notice how we use the array apply method along with a list of values, and the return type is an array of strings. We can access elements using the index notation. Notice how arrays are indexed starting from 0. We can also go ahead and change elements of an array. Here, for instance, we have reassigned element 0 to be the string Manic Monday. And if we now print out the contents of the entire array, we can see that we have successfully altered the first element of this array. That gets us to the end of this module. In the next module, we'll get to some really exciting topics, specifically how higher order functions work with Scala's collections. Effectively, these are functions which take in function objects and then apply those function objects to the contents of Scala's collections in all kinds of interesting ways. This topic will tie everything together. It will bring together our knowledge of functions and also our knowledge of collections. But before we get there, let's summarize everything that we've just covered. We covered a lot of ground in this module. We made a quick but pretty deep tour of Scala's containers and collections. We started with a look at how tuples can be used as substitutes for lightweight classes. We then worked with Scala's core collections, lists, and maps, and performed a bunch of interesting operations with them. And then we wound up the module with a look at error handling using options and util.try. And for completeness, we also covered the use of mutable collections and arrays.